Hello, I'm Grandmaster C, and you've seen me on a number of educational videos in the past. Mr. Canu asked me to take this last run of engineering, dealing with aerospace engineering. You know, the only way to do aerospace engineering is to wrap that scarf around, get ready, because for us, we're heading into aerospace engineering. But the essential question to ask yourselves is, if we did not fly out into space, what would we have missed out? All right, let's take a look at our objectives here. So you're going to define aerospace engineering, and you're going to explain Newton's laws of motion. Well, of course, that's kind of important. It's a physics concept. You're also going to understand the roles of fluid mechanics and aerodynamics in aerospace engineering. You're going to understand the laws of conservation. So today we're going to be looking at the basics of with Newton's laws of motion. And of course, with that, ladies and gentlemen, what better way to head into aero engineering like this? God bless the 80s. Woo! Okay. I don't want to get in trouble with YouTube or it's too many seconds of music, but you get the idea. This is Flight, and that came from the original movie Top Gun. Please, I can't believe they're doing a remake. Please, and Tom Cruise is too old to fly. I'm just saying. Anyways, aerospace engineering. What's the point? Design, build, analyze, troubleshoot aircraft, spacecraft, missile, high-altitude vehicle components. That would also include things like helicopters, which are rotary wing aircraft. The aircraft most people think about, they're fixed wing aircraft. There's aeronautical engineering. There's also astronautical engineering as well. So, professional aspects. Bachelor's degree for entry-level positions. Aircraft industry, U.S. Department of Defense, NASA. My friend, who you saw in the chapter dealing with biological engineering, he was actually offered a job to work for NASA. He turned it down. The pay was not that good for him. Hey. Associate's degree, aerospace engineering, technology, manufacture, or maintenance. American Institute of Aeronautics and Astronautics. That is a professional organization for that. So when we look at professional ethics, that's kind of an important thing, you would tend to think. All right, health, safety is the public primary focus, of course. You don't want planes or rockets crashing to the ground, especially in places where people are, want that. To act, of course, in a professional manner and must be qualified to accept projects. Teamwork, communication skills are critical. And again, ethics, okay? Like the Bible, the source of all ethics. What is it doing? Okay. So aerospace engineering principles. Well, let's take a look at the basic aerospace engineering principles, shall we? Newton's laws, fluid mechanics, laws of conservation, and principles of flight. So let's go to Newton's law. Sir Isaac Newton. The dude covered a lot of things. Like in physics, classical mechanics, Newton covers a lot. And his 3 laws of motion, notice they're laws. They're not theories. They're not hypotheses. They're laws, okay? There's no argument, all right? So what did Newton do exactly? I mean, there's people there who have taken physics and they're saying memory lane. Some of you guys, you've heard maybe Newton back in middle school. The guy defined laws of motion and universal gravitation. He predicted the movement of stars and planets. And given the information he had and the equipment he had at the time, he made pretty reasonable calculations. Now today it's a little bit different. But we're really focusing on the first, second, third laws of motion. Because seriously, it not just impacted physics, but aerospace engineering as well. And that is a portrait of him as a young man. Now, the first law of motion, every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. English. How about the English part? Objects that stay at rest, and not objects that should be, objects that stay at rest, objects in motion stay in motion, unless acted on by an outside force. So another way to look at this is if you have your wallet on the table, okay, there's no earthquake, there's no breeze, the wallet is on the table, it won't move. It will stay there unless something from the outside forces it to move, like your hand when you push it across the table. That would be an example of an outside force that's acting on it. Okay? Now, what about if you're on the slope of a hillside? Well, you've got forces of gravity that will also pull down on you. And if that's unbalanced, then yeah, you could slip. But for now, we're just looking at aircraft, spacecraft, things like that. So when we look at it, here is more of a visual of Newton's first law as applied to airplanes, because that's the focus of this chapter, okay? So very useful, because when you have airspeed, you have thrust and you have drag, okay? You want more thrust than drag because that's what allows you to move forward. And this is an official NASA slide. I'm just saying. How about second law? The force is equal to change in momentum per change in time. For constant mass, force equals mass times acceleration. For physics people, yeah, this might bring back some memories. Okay, but for the rest of you guys, if you look at, there is a relationship, there is a connection of mass, velocity, and time. Okay, there's a definite connection. When we talk about momentum, we're looking at mass times velocity. Okay, so could you have a basketball have the same momentum as a bowling ball? Yes, if you make the basketball move fast enough. Okay. On the other side of the coin, there is a change in time. Well, velocity, the velocity is another way of saying speed, but it's speed with a direction. Velocity over time is in fact acceleration. So we can talk about force equaling mass times acceleration, or the force is equal to the change in momentum over the change in time. It's the same idea. You have mass, velocity divided by time. That's what's happening. Okay, and of course the velocity will change when a force is applied. This is not a big surprise. Okay, so when we look at Newton's second law, there are a few different formulas here that kind of help you out a little bit. Now, am I testing you guys on the formulas? No. I am, I've taught physics. We've worked with these formulas before. It's kind of cool. You get to find out some things. Now, those formulas don't take into account things like air resistance, the humidity in the air. There's a lot of little things that also affect the momentum of aircraft or the momentum of any object, okay? How about force and lift, okay? When we look at force and lift, we have to look at the idea of the wing. What's the point of the wing? When you look at the wing, okay, the wing itself is going to be positioned at a certain angle, okay? And what it does, it creates a downward force on air, which increases the upward force on the wing. In other words, it creates the lift. So when you've got the wing there and you've got the air coming in, a lot of the air is going to go underneath the wing. There's not as much air here, so it's easier for the wing to go up. That's the idea behind the lift, okay? That upward force on the wing. Now, it's not just for aircraft, but this is also how helicopters work with the main rotor blade, because you can change the angle that the wing is at on the helicopter. You can't really change the entire wing of a plane, but there are controls on a plane that you can do some changes. But for a helicopter, the rotor blades, they can change like this, they can change like that, okay? It depends what's needed, how much lift is needed. But the same idea exists in both cases. Okay, so again, in aircraft, wing goes downward on force, goes downward force. Okay, let me try that again. It's in the afternoon. I am tired. Let's try again. In aircraft, the wing creates the downward force on the air, which creates the upward force on the wing. That's the lift. That's what you want. And guess what? Birds do the same thing. There are birds that they flap and flap and flap. Then you got birds that they soar. They look at what are called thermals, the warm air rising, and they're just there. And they seem to be hanging in one spot there. Birds are smart. Okay. Let's take a look at Newton's third law of motion here, our last one. This is a classic. In Newton's third law of motion, for every action, there's an equal and opposite reaction. We have what's called the thrust. The idea behind the thrust, you create it by forcing air to the rear of the plane. Now, you're going to put pressure on it because that's what allows the air to go out from the back of the plane, but it provides that thrust forward, that force that makes the plane move forward. As that air is forced toward the rear, the plane is forced forward. Okay? Now, that being said, the easiest way to show about for every action there's an equal and opposite reaction, you could take a balloon, blow it up, and let it go and watch the balloon go. Right? Same idea. Real simple. Okay? But that's Newton's third law of motion. Trust me, little kids love that. So with that idea, okay, that's where the rocket engine thrust comes in, where we can exhaust flow is pushed backwards out there and it forces the rocket to move forward. Thus the idea of an equal and opposite reaction. Now, you're saying, well, this is aircraft and I'm kind of not seeing that. Well, think about when you're driving a car, all right, and you have to slam on the brakes all of a sudden, right? There is... yeah, no, I'm not going to get into it. I'm not going to get into it about the car. Don't worry about it. Okay, however, shooting a firearm, that's a perfect example of the recoil versus the bullet coming out. Okay, perfect example. All right, we're gonna kind of wind down here. Gonna talk a little bit about fluid mechanics for this one. It's the study of fluids, both liquid and gas, and forces that act on them. So we have things like fluid statics, fluid dynamics, and if you look at the picture there, that's a wind tunnel. And this is a way of testing aircraft design to see how well does the design handle the airflow that's coming in. Now, of course, when we talk about aerodynamics, you have airflow around the solid objects themselves. And that's a fairly important idea because this is what's going to be the difference between a plane going up or not. So before we go create new aircraft, we have to be able to create models and test them in wind tunnels. And that's where the fluid mechanics come in, even though the fluid mechanics also apply to the aircraft in flight. This is also why airplanes flying in rough weather, where there's a lot of storms, the pilot has to be very careful in how they do that because there's a lot of changes that go on with the airflow up there. Just saying. So let's wind down here with the laws of conservation. 1. The law of conservation of mass. Mass cannot be created or destroyed. Oh, wow, that's a shocker. Okay, the law of conservation of momentum. The momentum remains constant until acted on by a force. That is also true. Okay, it changes. It's not lost, it's not destroyed, but it does change. Just like mass, the conservation of mass. Mass doesn't get created or destroyed, it changes form. Okay? Now, there's also the law of conservation of energy. Energy cannot be created or destroyed. Okay? That is also true if you think about burning gasoline in the engine. You've got exhaust coming out, you've got a lot of heat being given off by the burning of the gasoline. okay, that's inside the engine. You also have the mechanical energy. So it's not that the gasoline as an energy form is destroyed, it's changed into different forms, and it doesn't violate the laws of conservation. Okay, so wrapping up, what have we covered? Well, we have talked about the laws of conservation. We looked at Newton's third law. For every action, there's an equal and opposite reaction. Talked about the idea of force and lift with wings. And this is basically how planes can fly, how it's possible for them. Okay, as we looked at Newton's second law, looking at the change in momentum per change in time, that's our force, which is another way of saying mass times acceleration. Okay, we also looked at Newton's first law. Okay, for every object that's at rest, it's going to stay that way unless something from the outside acts on it. If you have an object that's in motion, it's going to stay in motion unless something outside acts on it. Does air friction count as something acting outside on an airplane that is moving? Yes, absolutely. As we move on here, okay, we looked at some of the basic ideas of fluid mechanics, a little bit, Newton's laws, laws of conservation. We're going to get into the principles of flight the next time. Okay, talked about the ethics, professional aspects of being an aeronautical engineer. We looked at aerospace engineering. Okay, and with that, ladies and gentlemen, I leave you with a question. If we did not fly out into space, what would we have missed out? Hey, this is Grandmaster C. It's been fun, but I'm going to sign off, and I'll catch you at the next unveiling of my upcoming album party.